Okay, today in regular chemistry, we are starting chapter 6, the periodic table. So we'll do two videos, one that talks about the development of the periodic table and just going back over some things about the periodic table that we've talked about before. That will go with one homework set, and then we'll talk about periodic trends, and that will go with another set. So hopefully you have printed off your periodic table that I have written some arrows on, and that's where we're going to write some trends at. Okay, early attempts. So one of the first gentlemen that tried to develop a periodic table of some type was John Newland in 1864. And he developed something called the law of octa. So octa means 8. So when he arranged some elements by their atomic mass, their properties would repeat every 8th element. It was not widely accepted, and the elements that had been discovered would not always fit. Then Dmitri Mendeleev in 1869 developed a table where he arranged the elements by increasing atomic mass and found similar properties would repeat at regular intervals, and such a pattern was called periodic, and so that's where they got the name periodic table. However, some elements, if he placed them by mass, they did not fit in the correct group, so he would adjust them and fit them into the group that they should fit in. His table had many gaps, so he predicted that new elements would be discovered and would fit into the gaps, and he went so far as to predict the physical and chemical properties of these not yet discovered elements. So he was a pretty forward thinker. The table that we use today, since Mendeleev's time, the noble gases and the lanthanide and actinide series have been discovered and placed into the table. So if you'll recall, the noble gases are those in 8A, and then at the bottom, the lanthanide and the actinide series have been placed in. Henry Moseley in 1911 worked with Rutherford. Remember, Rutherford did the gold-foil experiment that showed the atom was mainly empty space. He showed that the basis for placing elements in the table was by increasing atomic number. So the elements put in the table will be by increasing atomic number, which tells you the number of protons. So periodic law just simply says the properties of elements are a periodic function of their atomic number. If you arrange elements by their atomic number, elements with similar properties will fall in the same column or group. So remember, your groups or your families are in vertical columns. Okay, using the periodic table, so what we're about to talk about is pretty much a review from another chapter. The table has periods and it has families, periods. So on your table, there are 7 periods. So these are the horizontal rows, and they are numbered 1 to 7. 7 horizontal rows with elements arranged according to their atomic number. The number of the period corresponds to the outermost energy level in which electrons are located in the neutral atom. So remember, we talked about energy levels in the last chapter. So that means everyone in this family, which is only, in this period, hydrogen and helium are putting electrons in their first energy level. Into this family, this period has these elements are their outermost level of electrons are placed in the second energy level. For this period, the outermost energy level are putting electrons in the third energy level. Groups or families are the vertical columns. So on your table, they're numbered like 1 through 18, or like 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A, and then these in the middle have B's with their number. Those with the A are called main or representative groups. Their group number is related to the number of valence electrons, which are the electrons in their outermost energy level. Elements in these groups will have similar chemical properties because they have the same number of valence electrons. So on your table above this family, you should have this already written on the table, but if you don't, you can say these have 1 valence electron, or 1 VE. This family has 2 valence electrons. This family has 3, 4, 5, 6, 7, 8, with the exception of helium. These guys in the middle, their number of valence electrons changes depending on who you put them with. Elements in these groups will have similar chemical properties because they have the same number of valence electrons. Now, we named these families the other day. Hopefully you have them written on a table. If not, you can come back and add the names here. Group 1A are called the alkali metals. They are the most reactive metals because they have one valence electron and they want to get rid of it. Group 2A are the alkaline earth metals. They're also reactive. They're going to get rid of both of them. They're not going to just get rid of one of them. Group 6A, right here, those are the chalcogens. 7A are the halogens. They are the most reactive nonmetals. They have 7 valence electrons. They want 8, so they only need to pick up 1. So they will react vigorously with most metals to form what we call a salt. Group 8A are called the noble or inert gases. They are not reactive because their outer energy level, the S and P sublevels, are filled. So they have 2 in their S and they have 6 in their P's. Group B, these elements here in the center and down below are called the transition metals. They are filled in the D sublevels, and then the inner transition metals, these down here, are filled in the F sublevels. In the inner transition, you have the lanthanide series, and then you have the actinide series. The lanthanide series are also called the rare earth metals, and then the actinides, and they're shiny and reactive. And then the actinide series are all unstable and they're radioactive. The first 4 of the actinide series are found naturally, so you would have thorium, protactinium, uranium, neptunium. These are found in nature, and the rest were synthesized in lab. Okay, the next thing we can do is we can classify elements into 3 main classes. We've already talked about this. You have your metals, you have your nonmetals, and you have your metalloids. Metals will have a metallic luster. That just simply means that when they're clean and smooth, they will shine. They are solids at room temp with the exception of mercury, Hg, which is a liquid. They are good conductors of heat and electricity. Most metals are ductile and malleable. Ductile, if you'll recall, means that you can pull them into a string. Malleable means you can hammer them into a sheet. They are located to the left of the stair step. Most elements are metals. In general, they will have 1, 2, or 3 valence electrons. So remember, we said this family has 1, this family 2, and 3A has 3, which they will lose when forming an ionic compound. So we'll get into ionic compounds in the next chapter, but ionic compounds basically occur between metals and nonmetals. So your metals always give up electrons, and your nonmetals will accept them. And these can give up 1, 2, or 3, depending on which family they're from. And nitrogen, oxygen, fluorines families can gain 3, 2, 1. When they lose an electron, they form a positive ion because they have gotten rid of negative things, and you call them a cation. And you can think of that T as a positive sign. Nonmetals are generally gases or dull, brittle solids. So, for instance, carbon and sulfur are solids, but they are brittle and they are dull. Bromine is a red liquid. They are not good conductors. They are poor conductors of heat and electricity. They are located to the right of the stair step, and in general, they will have 5, 6, or 7 valence electrons. When forming an ionic compound, they tend to gain electrons. However, if you put a metal and a nonmetal, metals give them up, nonmetals gain them. Nonmetals can also share electrons with other nonmetals, and that makes a covalent compound. So they can also share electrons when forming covalent bonds with other nonmetals. When they gain electrons, you call them an anion. So an ion is an atom that has either lost or gained electrons. There are 2 types. There are cations and anions. Now, as you move down a group, metallic characteristics increase and non-metallic characteristics decrease. And then as you move across a period, metallic characteristics decrease and non-metallic characteristics increase. So all we're saying is as you go down a family or group, these electrons are getting further and further from the nucleus, and so they're easier lost. As you go across, you're putting electrons in the same energy level, and so they are not as metallic. And then your metalloids, we marked those the other day, are sometimes called semi-metals. They are the ones that border the stair step, other than aluminum and I think it's just aluminum. Okay, so metalloids are your semi-metals. They border the stair step. They generally look metallic, but they're also brittle, so they're not malleable nor ductile. And we sometimes call them semiconductors because they're not necessarily good conductors or insulators. Okay, so that finishes up this first video, and so this goes with set 1, the periodic table homework set.